Good morning, everybody. This is the last lesson we've got on complex numbers and geometry, and it also marks, I think, the last lesson of your core work for this year. Not sure if that's a celebration or not, really. I don't think it would be if it was me. So we're going to finish this last bit off today. Tomorrow I'm going to set you some extra work, and I'll post the solutions as well on the things we've done in this chapter. And then on Wednesday, what I'd like you guys to do is sit down and have a go at the topic test. The topic test doesn't have to be done in test conditions. Feel free to use your book if you need to, but I do want you guys to do it, and I want you to send it to me and Mr. Clark so we can have a look and get them marked and get them back to you. So on Wednesday, try and I probably, if you can put 2 hours aside on Wednesday, then that'll be more than sufficient probably to get that done. And I'll just I'll let you know when the deadline for that is. It might be Friday, I think, probably. Anyway, let's crack on what we're meant to be doing today. So we're meant to be doing argument and loci today. We finished the stuff with circles the other day to do with modulus. And also some straight lines for the loci between 2 points. That was when the two circles intersected with each other. And today we're going to look at the arguments sort of stuff. So let's get going. I'm ready to stop saying I'll try and stop. So this is, I've done it already, an Argand diagram, and I've got some line coming out of the origin. And the angle between the line and the initial line, or the real axis, is theta. Now I'm going to say that this line represents the following. The argument of z is equal to theta. What this means is what z values have an argument of theta. Well, any complex number on this line, because the angle between the line and the real axis is theta, any complex number on this line must have an argument of theta. There is one thing at the moment which I haven't quite mentioned, and that's the origin. What I should have is a little circle here, an open circle, to signify that this particular point, the origin, is not defined, because there is no angle that exists there, because at the origin there's not two lines to measure between. So that's not defined. And when you have a line which looks like this, it goes off in one direction only. The starting point isn't included, hence the open circle. We call it, unsurprisingly, a half line. So this is called a half line. And half lines are really useful when you're doing arguments, especially with loci. So what we want to do is look at some slightly more interesting ones. So instead of having argument of z equals theta, how about if I said instead, let's put that imaginary and that real, argument of z take away 1 plus 4i. Notice that I'm using the brackets like I was the other day. Notice there's a negative sign there, not a plus. And this equals theta. So I'm going to hypothesize based on what we did the other day, and I'm going to then see if it makes sense, that I need to start or have something to do with the complex number 1 plus 4i. So let's say that's there. There's 1 plus 4i. And the angle theta, I'm just going to draw an angle at a line off at the same angle. So if I just do a dotted line here just to signify that it is actually theta. Okay, so that dotted line is parallel to the real axis. Let's call that theta. So this is my first guess. I have used an open circle to mark where 1 plus 4i is, because I know that's not included because there's not two lines there to make an angle. I have a half line coming out in the direction of theta. I've got the dotted line just to signify that that's parallel to the real axis, so this is actually theta. And now I need to decide, does this actually make any sense for me doing it this way? So the way we can make sense of this is by thinking of translations. So at the moment, 1 plus 4i is the vector which takes me from here to here. And if I did minus 1 plus 4i, it would take me from here back to the origin. And if I think about that for every single point on this line, it drags me back in that direction, drags me back in that direction, drags me back in this direction. If I did that to every single point, I'd actually get this line back again. And that obviously has an argument of theta. So this seems to work. If I have the argument of z minus 1 plus 4i equals theta, it is just a half line which starts at this complex number. There has to be a minus sign here, and then the half line goes off in whichever direction theta should be, measured in relative to the dotted line, which is parallel to the real axis. So that's how you can believe this, I suppose. If you really don't believe that just yet, then draw a scaled version of this using some square paper, and just drag every single point, or as many points as you can find on that line, back by 1 and then 4 down. You will just get this line again. So that's really useful to note. That's going to help us with the next bit. So let's just do 2 examples of this quickly. You guys can have a go at 2 examples of this, and we'll just check that we've got the same things. So can you try first of all to draw me a diagram that represents this: z plus 1 plus 2i equals pi over 3. I'll try not to make a mistake in my answers today like I did last week. I'm very sorry for that. And the second one, can we do the argument of z take away 2 take away I equals negative pi over 2. Okay, so have a quick go at those, pause the video, and then come back to me when you've done that. So hopefully for this one, you've just drawn yourself a little diagram. They don't have to be particularly big. They don't have to be particularly accurate either. They just need to be obvious, I suppose is the right way to describe it. So before I can start drawing my diagram, I need to look at this and say, oops, that's not quite in the right format just yet. And it's still not if I put a plus sign there. So if I do a minus there, then it's going to have to be a minus I minus 2i. I've got that complex number in brackets here, nested within the other brackets. Let's just distribute back over. Minus times a minus is a plus, minus times a minus is a plus, so that checks out. So I need to draw a circle at minus 1 minus 2i, minus 1 minus 2i. The best way to signify that is by putting minus 1 minus 2i on there. And then you need to say to yourself, okay, so it's pi over 3. Pi is 180 degrees, divided by 3 is going to be 60 degrees. So generally off in that direction, so basically a little bit further around from 45 is probably the best way to suggest that one. With this, be very careful about where it goes in relation to the origin. So it should go, I think, just to the right of the origin, or just underneath the origin. And then make sure you have your dotted line coming out here. If you're in an exam and you had that the other side of the origin, you may possibly lose marks. I can imagine they probably wouldn't have set an example like this to catch you out like that. However, you should still think about it, and you can quickly do it by just saying, well, that's 2 there, that's 1 there. So you can work out what this angle would be. using that idea. So if you've got the opposite, you've got the adjacent side. You can use tangent to find out what this angle is in here, and I'm assuming that that angle to go through the origin would be bigger than theta, or bigger than pi over 3. Oops, pi over 3 that should be. For this one, a bit more straightforward. Make sure that it goes into the right form. It already has a minus there, which is good. So minus 2. I need a minus I, so that's going to have to be a plus I. Minus pi over 2. Just check it distributes well. Minus times that is minus 2. That times that is minus I. Good. So 2 plus I. 2 and then up a bit. 2 I. Minus pi over 2. That's going to be fairly easy to do. So there's my initial line, and the half line comes down here. It doesn't matter how long the half line is. Don't get yourself worked up about that at all. Minus pi over 2 in there. Make sure though that that circle is there. If it's anything, if it's just nothing, if there's just no circle at all, or if you've coloured the circle in, you could well lose marks there. So please be careful with that. Ouch. I don't think there's anything else to do on that particular bit or say. No, I don't think so. Good. Okay. So what we would like to finish off with today before you go and do some exercises is looking at some inequalities. So how about I had something a bit more exciting? How about I had minus pi over 2 less than the argument of z, use what we just used, z minus 2 plus I, and that's going to be less than or equal to 3 pi over 4. Okay, so what I'd like you guys to do is shade the region that satisfies this. So pause the video, have a quick go, and then come back to me when you think you've done it. So hopefully what you've done is you've noted that this is in the right form, so we don't need to do anything about that at least. And because there's a bit more going on, I would suggest to you to draw a slightly bigger diagram. The more that's going on, the bigger the diagram, generally the better. So minus 2 plus I, so 2 plus I is still here. I'm going to stick my circle there. I'm going to signify that it's I and it's 2. So 3/4 pi is off in this direction at a 45-degree angle. You don't need to worry about sticking the intercept on here. Sometimes it's useful for a later part of the question if you know what it is, but if it's a straightforward question, don't worry about it. However, I'm sure you could probably work it out quite easily. With all of these things, a bit of right angle trigonometry can normally get you out of a sticky situation. So it has to be round to there. There's a quality in here, so I've got no problem with drawing that sort of line there. And in this scenario, I've got minus pi over 2. However, there is no equality here. It's a strict inequality. And so I'm going to use a dotted line to represent this. Now, this is sometimes where you can get a little bit confused with your picture because you've got a dotted line here, you've got a dotted line there. So you've got two situations. You can rub this off afterwards to make it look a bit tidier. However, what I would suggest you do is actually mark on that this is 3 pi over 4, that this is minus pi over 2. So you're showing the examiner that you know that you need to do a solid line, you know you need to do a dotted line. You've got the angles on there clearly, so you're showing that you understand that idea. And then in terms of shading, we're shading the bit we want. So if you just shade like that, that's more than sufficient. Please, please, please do not start shading it in fancy in some way or spending half an hour doing it. Just a load of lines like that, basically just making it obvious that it's that bit and not this bit. This is obviously quite important that you do use the idea of going between minus pi and pi with this sort of thing. You can do it with stuff over 2 pi, but just stuff over pi, but just assume for especially this stuff that you're going between minus pi and pi. In fact, you probably should do just for the whole course, really. I'm not quite sure why I mentioned it the other day. So that's all that we needed to do today, and that's the last bit that you need to know for the pure content of Year 12. So what I'd like you guys to do is go back to exercise 5.3. There's quite a few questions which you didn't do the other day. Can you make sure that you've done all of the green and the orange sections, and if you're super cool, have a go at the red ones as well. I will speak to you again very briefly tomorrow with the work, actually no, I won't speak to you tomorrow about it. The work for tomorrow will be set up on class charts and will also be on the VLE. It will have a date next to it, and it's just some extra questions to do with this work so far. And then on Wednesday, you guys will have a test, and on Thursday will be your next video. I haven't quite decided what that's going to be yet. It might be that we start mechanics, it might be that we very, very quickly finish off the numerical methods, but I'm not too worried about when we do that because it's such a small bit. Yeah, so I think it's going to be one of those two things. If anyone's got a particular wish either way, then please let me know. And I'll speak to you again on Thursday. Take care, bye-bye.